Okay, good afternoon. So I will continue this lesson on the derivative that's from section 3.1 in your textbook. Two interpretations of the derivative. First one is that f prime of a is the slope of the tangent line to y is equal to f of x and x equal to a. So in the last video I defined f prime of a as a limit. If you look over here, this is what we mean by tangent line. Tangent line comes from the Latin word tangens, meaning touching. This is a function, y is equal to f of x. Notice it's the exponential function. And this is the tangent line. It just touches the function at this point, in this case 0, 1. And as you know from before, lines have slopes as well as points that they go through. The second interpretation of the derivative is the instantaneous rate at which output changes per unit change in input when the input is equal to a. Now, the example here that I gave is if the input is time in hours, let's say of a car that's traveling from UH Manoa off campus, f of x is the distance that car travels in miles, then f prime of a is going to be the miles per hour of the car in hour A. So if you notice, if you're driving in a car, right, at each hour, you can look, every hour you can look at the speedometer, and the speedometer will have a value. That speedometer will point to a certain speed, say 60 miles an hour. That is how you're going. Or maybe if you're traveling, that's after 1 hour getting on the freeway, or maybe after 2 hours you get back on a small road. Now the speedometer is reading a smaller value of 30 miles an hour. This is hour 2. This is hour 1. So at each of those places, your speed is changed from 60 miles an hour to 30 miles an hour. Calculus allows us to determine what speed of objects is if we know the function that gives the distance that object travels.